They consumes a lot of power. Now my question is to the audience that how to resolve these issues. Anyone, any solution? Question is clear. How to reduce the power consumption for data centers? Because data centers are actually producing huge amount of energy. A lot of cooling is required for the data centers. Do you agree? Hello.
তখন ওই লোকটার সাথে কথা বলতেছিলাম, তখন এগুলো ফোন করছি।
Huge amount of energy is coming from those data centers, right?
এই তো কেস,
So
খাওয়ার কি আছে?
let me just check it.
8 million data centers around the world are processing our entire online lives thousands of times a second. But Microsoft, and it may be for the better, with our reliance on cloud-based services expected to be at an all-time high in 2021.
হ্যাঁ, দেওয়া নেই কেন?
Fueled by the ongoing pandemic, the need for the most energy and time-efficient data centers is crucial moving forward. Microsoft has just reached the end of a 2-year Stage 2 experiment, sinking our data to the ocean floor. And here's why this is big news. On the 9th of July 2020, the tech giant Day-2 calls its Northern Isles, a 12.2-meter long steel cylinder from the sea. The giant tube remained 117 feet below the surface for 2 years, gathering data which would later be analysed by engineers. The company chose to locate this long-term experiment 10 miles off the coast of Scotland in the Orkney Isles archipelago. Here, 100% of the energy comes from environmental sources such as wind and solar. The problem with data centers on land is that they are subject to a battering from all directions. From the oxygen and humidity in the air, land-based facilities face the serious threat of corrosion. Temperature fluctuations prove to be costly for the cooling systems required to keep the servers at peak operational temperature. Of course, the constant foot traffic from cleaning and maintenance teams can also be a cause for concern, with bumps, jostles, and genuine accidents jeopardizing the equipment's longevity. Sinking this facility in an airtight, waterproof container alleviates some of these concerns. Consistently cool temperatures, for example, help with thermoregulation. That means less energy required to keep the computers cool, a plus for the environment as well as our pockets. About 1/5 of a data center's energy requirements are destined for keeping the cool temperature, but this is reduced to a minimum when surrounded naturally by seawater. The flexibility of Project Natick, the codename given to this research exercise, helps alleviate concerns that traditional land-based data centers have over natural disasters and other attacks. After all, breaking into a conventional data center with its highly trained armed security seems easy compared to reaching it on the sea floor. More than 50% of the world's population lives within 120 miles of the coast. That's about 2 hours by car. While conventional warehouses are located miles away from cities, often in the middle of nowhere, having access within a stone's throw means a shorter distance for data to travel, saving energy and providing lightning-fast access to consumers. Due to the shift in cloud-based computing, experts believe it would be more beneficial in terms of energy and providing a stable access to customers to have multiple smaller data centers dispersed among populations rather than drawing from one external warehouse. There will still be the right time and the right place for housing data on land, but it will inevitably become less common. The project envisions its offshore submerged vessels being powered by partnering wind farms. Previously thought of as an unreliable source of electricity, the uninterrupted winds at sea make it the perfect pairing. However, along with the fiber optic cable linking the tubes to land, which are necessary to transfer data, an entwined power line could provide a backup source. Thought up at Microsoft's Think Week 2014, an annual event where employees share advanced new ideas, the project required a multinational effort to make it happen. The cylinder, for example, was built by French shipbuilder Naval before being loaded with its servers and sent on its way to its Scottish residence. There, the European Marine Energy Centre hooked it up with its underwater cables before it was sunk in June 2018. The unit, whose internal diameter measures 2.8 meters, required endless negotiating and communication to sink, resulting in an entire day's work. Everyone involved had to wait for calm waters to perform the seafloor surgery, whether that is not typical for the region of the North Sea. Out inside, 864 servers with a combined output of 27.6 petabytes. That's 27.6 million gigabytes. Enough storage to retain nearly 5 million movies, or the equivalent of over 100,000 MacBooks. So the Northern Isles spent just over 2 years under the sea gathering data along its journey. What do we know about the project? Was it a success? Another full day of retrieval pulled up the same white container, with with a thin covering of algae, barnacles, and sea anemones. A quick wash resulted in surprisingly clean bodywork emerging from underneath. From this one experiment, the various teams of engineers and researchers at Microsoft have deduced that syncing a data center like this is 8 times more reliable than housing computers in land-based warehouses. Although why, we're not sure. Despite a handful of failed servers which were taken off.
So hello. Hello. Can you hear me?
Yes, sir. Yes, sir.
Yeah. So what we have observed that this data centers like Facebook and others, they're putting these data centers in the in the cities or the villages, and huge amount of air condition is involved, right? But if you have seen that that underwater system is a data center developed by Microsoft, and which was in the just when the pandemic started in the July 2020, and for 2 years they have collected huge amount of data. Unbelievable, isn't it? And moreover, that do not require any cooling. No cooling is required, and that is the beauty of the whole system. No cooling is required. So you understand, it reduces almost 90%. This one is reduces almost 80 to 90%. It's possible. So even it can go below the Indian power consumption. So that is the way we can we have to think something out of the box, and we have to reduce this power consumption. Okay. So these are the graphs showing the power consumption needed, power needed, because we are now mostly online. Now, see, this is the Little Library 2016 one. Still, if you see this picture, the major companies, Google, their most power consumption is coming from the wind energy. This blue line indicates the wind energy, and this yellow line indicates the solar energy. Google, most of the power is coming from uh, wind energy, right? Amazon, see, this is the yellow versus blue. This is for US defense, Microsoft, mostly blue, right? And Facebook, almost blue. So see, these are the, Apple still is in yellow, there are various other companies, right? It shows you basically, they are all using this, this mostly the non-conventional energy resources to run their data servers. This is a very important need for the hour, to reduce the carbon footprint, right? As Deeptiman was talking about, that we have to make the system green. So what I mentioned, that we have to reduce the complexity of the system. One is the time complexity, space complexity. Everyone know this too. Energy complexity is another very important. We have to reduce the energy consumption. Okay. So to reduce the energy consumption, I think you remember the lecture of Dipti he was talking about that load balancing or migration. He has mentioned, what is that? The birds fly from one country to other country. What is the reason behind it? Can anyone say? Why these migratory birds fly from one country to other place, one place to other place? They make a long journey. Why? What is the reason behind it? They go for the food, and they go for the temperature, weather. So these are the two important needs. Similarly, when we are talking about smart environment, energy movement, then we have to migrate the VMs. VM means virtual machines. The cloud, we have virtual machines, right? Migration of VMs are very important. We have to do for multi-cloud processing and smart neighborhood. These are the important keywords that are coming up. And we have to go for software-defined Internet of Energies, right? So we have to migrate the VM. How VM migrates? Let's see an example. In this example, you can see there is a picture of Australia, where the job is migrating from one place to other place. If the sunlight is high, this area where the sunlight wind power is high, more jobs will be migrated from this area to this area where the energy consumption is high. So you remember, when the sun rises from the east, right? Sun rises from the east, right? When sun rises, most of the jobs will migrate towards the east. Amazon, for example, Amazon has server all over the world. Now there is a sunlight in, say, Australia, then whatever the things we are performing in the cloud applications, the cloud application will jump to the servers in Australia because sunlight is available those areas, right? Or the wind energy in the, or you can, it's similarly true for the wind energy also, right? So we have to migrate our jobs from those areas where the sunlight is not there to those areas where the sunlight is available. Okay, so sunlight based job allocation or server allocation of jobs, right? So this is very, very important. Is it clear? Shadudal sir, is it clear?
Yes, sir.
So you understand that when we are using this cloud, we don't know where else our job is going. So job should go to those countries, those places where the sunlight or this energy is available. You know, sun moves, right? The earth moves. Accordingly, maybe after sometimes the job will be more job will be allocated to this country because sunlight will be here in India. Then we'll go to Africa. Then we'll go to US. By this way, the jobs will migrate from one place to other place based on the sunlight. Clear? Similarly, we also have a website called windy.com. There's wind map. The wind maps means it shows that how the wind moves from one place to other place. So based on the wind energy, we can shift the job, means the server job from one place to other place. It means, yeah, if the energy is high, then we can send the data to those areas, right? So you have seen this map, right? This Google or Amazon, they are putting the data centers in those areas where the wind energy is high, and wind energy is high in the, the higher equatorial regions. So they have to select those areas. The selection of the spot is based on the wind speed. Selection of this spot, the bright sunlight is available or not, right? Based on that, these companies, Google, Amazon, they choose the Microsoft, they select the spot or the zone where they will put their data centers. Okay, so that they can get the energy efficient system, energy at a very low cost. So this kind of migration is very important. Okay, also that another technique is called swarm technique, which is used for IoT or sensor network. This glowworm, means in Bengali we call it Jonaki Poka. They will fly like this, on the sky, and they make this. They connect to each other, and they make beautiful lightings in our environment, but they never collide. So these techniques, we can use it. This, I'm not going in detail of it because there are a lot of node movement systems are there. So they move accordingly to the light. So it shows that movement of the glowworm on the sky. So this is the MATLAB simulation of this glowworm. So if we can divide the area in a matrix and see every point there is a worm, this every grid, if there is a worm, then the movement of the grid, movement of the word in the grid will be according to the available resources, according to the sunlight or the energy what is available, right? So I'm not going in details of it. So we do some of the research for this grid movement. For example, you can see this grid movement is used for swarming of this UAVs. UAV means uh, the drones. Okay. Also, we have developed the fuzzy based swarm for coverage. Coverage swarm is there for giving the coverage, how the data centers will move, how these nodes will move, IoT nodes will move from one place to other place, right? So there are various techniques are there to carry out this problem. This term is called brownout. This is another second agenda of this today's talk. What is brownout? Anyone know what is brownout? Brownout is a one kind of energy condition where the resources are less. Means, say during this COVID pandemic, that we are all about to stay, supposed to stay at home. and even we cannot go to the food shops. Even all the foods are not available. That means we have to work in the system where there is less resource available. Here, brownout is a condition, energy condition, where the less energy is available in the system. Now the question is, it is reduction or the restriction of the availability of the electrical power in a particular area. See, restriction. During COVID, we have a lot of restriction, right? Now the restriction is a little bit over. Is availability of electrical power in the particular zone or area. Reduction or restriction. Very important. Now this brownout is actually helping to understand when we want to design the system. Means I can tell you one example. Electric bill, you are making this power consumption, you are making an electric pump in your system, water pump. If you make the pump on in the daytime, you have to pay say $5 per day, $5 per unit. Okay. If you make the same light pump on at the night, then what will happen? It will be $1. So what is the best time to make the light this pump on? It is best time is the night time. That is called SLA. SLA means service level agreement. SLA means service level agreement. Now why this SLA is coming in this brownout condition? Because to save the energy. Is it clear or not clear? SLA means service level agreement. When you are taking any service from the cloud or any kinds of services, whether it's from CESC, from any electric supplies, then SLA plays a major role. That means in the morning, daytime, all the factories and everything is on. So when you want to use this, your household devices on, then you have to pay more because there is a scarcity of electricity. But in the night, after say 5 p.m. or 6 p.m., all the factories are closed, most of the factories are closed, then the power, same power, the charges are low. So we have to make this kind of adaptive brownout agreement called SLA, service level agreement. We have to we have to develop the policy. We have to develop the energy policy for that, so that using this IoT we can control the whole system. The see first is a controller. There is a controller which can control that based on the schedule policy. So we can schedule the light or the fan will be on or the pump will be on at the night, right? We can schedule the policy based on the SLA. By this way we can reduce the workload. Workload means, what do you mean by workload here?
Consumption of the energy and the electricity.
Yes, yes. See, sir, you understand what is your name?
My name is Day-2.
Okay, so you
Day-2.
understand. Okay, so you have seen that in the daytime, the power, what you can say, it is a peak hour, right? Peak time. So all the factories are on, all the offices are on, all the street lights are on. Systems are on, not street lights. All the systems are on. So it requires huge amount of power, right? So if the government makes a SLA, service level agreement, that okay, light fan should be on, but pump should not be on. If you want to make the pump, means water pump, on in the daytime, you have to pay more. So it is better you schedule your pump based on the policy at night. So by this way, we can reduce the power consumption. Is it clear?
Yes, sir. But still, the WBACDCL and CEC doesn't have this right now.
Yes. So we have to, that we have to develop this kind of policy, right? As
Yes,
Diptiman
sir.
was mentioning that government is talking about, this power consumption. Power is not power either we are getting by the fossil fuels or we are getting by the sunlight, right? Power is limited. Agree or disagree? When you want to develop a sustainable society, we have to go for this policy. It is also by the policy we can save the system. So anything which is not needed immediately in the daytime, we can keep that job at the night, just like water pump on, just like other activities, the washing machine on, right? So maybe in future, maybe in after 5 to 10 years, you will be the policymaker. Those who are listening this talk, maybe some of them will be the policymakers. We have to make the policy in such a fashion we can reduce the carbon footprint. At the same time, we can do the proper resource allocation. When and where, what time we have to make our system on. For example, your pump, we can make it on at night. Your washing machine, you can wash your clothes. No need to wash the clothes at the daytime. So you can wash your clothes or your utensils at night at reduced costs of electricity. So cost of electricity is adaptive. You understand? It is adaptive because that is the reason I believe in self-adaptive system. We have to adapt the system in such a fashion. We have to do the batch processing. So see, it is written that you have to schedule the policy. Scheduling.